Okay, I'm going to show you how to get digital or depth and elevation model data. First thing, we're going to use USGS Earth Explorer, and to figure out how to use this, there's about a less than a 10-minute video here that I found that's very useful. So watch this video first. Okay, then we do the usual setup. And then let me show you where all this came from. I followed the instructions for getting data out of Earth Explorer, and you can see the area that I marked out, the polygon that I marked out, and then that gave me 4 pieces. And basically what they are is, well, it's much bigger than Thurston County, but I'll talk a little bit more about what these things are, but you have to download them all separately. It's interesting, I realized after working with this that you don't, it's not going to make up an exact depth elevation data set for you that matches exactly what you specify. It's got some predefined pieces, and it's going to download enough of the predefined pieces to capture what you want, and then a lot more, as we'll see. Okay? So the data that we load in, this comes from north 146, west 123, 1 degree of arc, to north 47, west 124, 1 degree of arc. Okay, so those are the 4 raster data sets that we're going to get. And there's a merge function in the raster package in R that allows you to take those 4 things and turn them into one raster, which I called whole_DEM. Okay, so that's the raster that we've got to work with. Okay, so let's get Thurston County, and I went back and just used the counties _US data, and got Thurston County, the usual thing. State FP is 53, name is Thurston. Then I converted Thurston to have the CRX of one of those 4 rasters. Okay, so look at the DEM data and Thurston County. So I've got the raster for all of the data that I've got, and then I threw in a Thurston County, and you can see that what happened is I said I only asked for something like this, but I got all of this because the minimum it can give you is 1 degree of arc in both latitude and longitude. Okay, so let's continue. So I trimmed the data down to fit Thurston County with the crop function. So DEM_crop is the crop of whole DEM, comma Thurston. And then we can look at the raster cropped down to fit Thurston County. You can see, yeah, it's cropped down to fit Thurston County. You can see how it just gives you a rectangle, the minimum rectangle that'll fit Thurston County. Then I decided to eliminate the non-Thurston data with a mask. So a mask DEM_crop, comma Thurston. And this is what we've got. So you can see, well, we'll talk about this a little bit later. It's broken down the things by just a few different categories of color. It's scrunched all the colors into just a few things. And we'll see how to fix that. So I did a mask, And I also used style is continuous. Misspelled that. Continuous. I'll have to fix that before I post the thing. So this is what you get with continuous colors rather than discrete colors. And that looks an awful lot more realistic to me. I can now recognize where I've got real water as opposed to land. Before, everything from 0 to 200 was the same color. Now this is water and makes sense. Okay, then I decided to try a different color scheme, blues, and I think I like this one better. Okay, so that's how you can, oh, notice what I did here. I didn't just say palette is blues, palette is quote negative blues. The negative sign goes within the quote marks to get the color things reversed. Otherwise, you get light colors are the lowest values and dark colors are the highest values, but I prefer it in this case this way.